To examine how to solve a problem like a hammock problem or any hanging object where there's two tension strings hanging about, and we need to find the tension of those two strings, which is exemplified here. So to begin, we got our free body diagram, we got the angle, we got the force of gravity, which is mg, and we got the tension forces. So then how we're going to do this is we have to start with breaking our force or tension components down. So then to begin, we'll have to start with the x component, and then we'll write an expression for the x component, and using that expression, we will use the y component that we find to sub into the x expression. So let's exemplify how that is done. So let's see, if we want to start with finding tension 1 in the x component, by the way, since tension 1 and tension 2 is the same because they both have angle 20, so what's going to happen is tension 1x, which is here, is going to have to be cos 20 times tension 1. It's just your simple trigonometry, and we're just writing an expression for it. Because cos, it's adjacent, and the x component is adjacent to this angle, so then that's how you would get cos 20 times the hypotenuse. It's just an expression. And then as I said, tension 1 and tension 2 is the same angle, so we're going to say, and it's going to be a negative because they're acting in different directions, and we want the net force. Plus a negative cos 20 times tension 2. You could write tension 1, but for our sake here, I'm just going to show how you could use that expression and substitute it in with your y component later. So then with this, the next step is we want to understand what's going on here with the net force. Because the hammock, the entire hanging object, is not moving, the net force would have to be 0 newtons. So with this expression, we can easily separate either T1 or T2 by mathematics. So let's just do that. I'm going to separate T1 by its own, just because it will be helpful for what we're going to do next with our y component. So this is just your simple isolation. And then this will have to cancel out. And then we see that tension 1 is equal to tension 2, which is perfect because that's what's happening here. It's the same angle. Okay, so now we're going to start with our y component, and you'll see where this expression will come in handy now. The y expression is also going to be similar. F net equals to tension 1 plus tension 2 and minus mg, which is a natural force. Sorry, the force of gravity. So to begin, we'll take a look here. There is no movement in the y direction, so net force is 0. Now you might ask, well, why did I write tension 1 plus tension 2 here, where before I wrote tension 1 minus tension 2? Well, let's take a look. Both of these y component forces are acting upwards. It's not going down. So then what happens when you add these two forces together is you get a net force up. So then you add instead of subtract. So then, since it's a y component, we're going to use trigonometry to write an expression for it again. So since it's opposite of the angle, we will use sine 20 times the hypotenuse, which in the expression it's tension 1. So here's where this expression that we got earlier becomes handy. So what we got was tension 1 equals tension 2. So then what we want to do here is we want to equate tension 1 and tension 2 together, so that in this expression, instead of writing, there we go. Instead of writing tension 1 here, plus sine tension 2, what we could do is just write sine 20 tension 1 plus sine 20 tension 2, and then substitute it in the equation we got earlier. But since we isolated tension 1 first, so I'll just make this tension 2 so that we can put it in here. Doesn't matter which one you go with. Anyways, and then this will be the same angle because they're the same. And I haven't mentioned this yet, but in this given question, the gravitational force is 245 newtons. So if your question gave you the mass, like a mass, instead of giving you how many newtons there are, what you would have to do is you want to find the weight by mass times gravity. So you times the mass times gravity, and then you get this, which is equivalent to newtons. So then there we get that. And then we'll need to isolate T2 so that we can substitute it into the earlier equation. So let's do that. Hopefully you can do that on your own. This is what we end up getting. Sine 20 times 2 equals T2. Okay. And then, all in all, the final answer is 1096 newtons. And that's tension 2. And because tension 2 and tension 1 is the same in this case, tension 1 is also this number.